The world is changing and transforming in a lot of areas. When you're thinking on artificial intelligence, for example, this changes all our life, how we work, how we live, how we creating new things. At the moment, we have new problems which are not there for the generations in the past, so we have to come up with new solutions to give the right answer to the problems we have right now.
At Kiel University, we link the atomic scale understanding to microscopic function, creating functional, advanced materials and devices that indeed can tackle the global challenges in energy, health, and sustainability. From atomic insights into global impact means to understand how atoms, molecules, and interfaces work, and how this knowledge can be used to design and develop functional materials. Each of these materials brings the future technologies closer to being both intelligent and sustainable.
Research and education are very closely connected at Kiel University. From the very beginning, in our department, we are focusing on training our students in our research laboratories. Students have opportunities to contribute to scientific discovery directly. This happens via bachelor thesis. We help our students think as innovators from the start. Practical and topic-related training are very important to us in our department. Our students can easily interact with us on the way to lunch or to lectures. So therefore, they don't hesitate to communicate with us or to discuss with us. This makes the educational environment exciting and special.
Working at Kiel University's Department of Material Science is like a family, so we always help each other with the problems, and that brings us the progress that we want, rather than trying to keep our research to ourselves. It's shared with everyone.
Functional materials for future technologies, they enable, for example, as medical materials function inside the body. As energy materials, they are powering things everywhere. We are trying to work with new discovered materials, combine them in new ways, and discover in this way new properties which we turn into applications at the end. You see the deepest insight if you visualize materials at the atomic scale. Getting insights into the atomic structure helps you to understand on this level what the macroscopic properties of materials are. Only if you understand things in theory, you can predict what you want to do. Simulations of materials allows us to understand what is the best sensitivity you can get out. These sensitivities are important, for example, to detect the tiny magnetic fields which a human heartbeat is doing. And in this way, it's kind of our toolbox in which we can do materials for sensing, magnetoelectric materials, we can do materials for energy, we can do materials for medicine.
If you have research and put the research behind a desk and never goes to the market, this is a waste of time and money. So I think is a strategy, and we are coming from that. Aquandas come from my PhD studies, and I could research and at the end I found a company. That is great.
One thing which is interesting in the research in Kiel is the interdisciplinarity. So here all groups work together in the department in a very nice collaborative way. Furthermore, they're working with medicine departments, with energy, with computer science, so that we can develop our materials to a higher level of application.
By that, we need the knowledge of many disciplines to actually make an impact on the big questions that are dealing today's society. A nice example actually is our work in the Collaborative Research Center Biomagnetic Interfaces, where material scientists are creating novel biomagnetic sensors, which are then assembled in the electrical engineering department to sensor systems. And finally, the medical doctors will work with these sensors on the patients in hospital. It is actually the Kiel Nano Surface and Interface Science Network, where over 150 scientists are working together from diverse fields, like for instance chemistry, physics, biology, the complete engineering, including the material science as well as the life sciences. And by this interdisciplinary, or to say even multidisciplinary approach, we are able to tackle big challenges in research which are also societally relevant. The essence of KINSYS is working together, creating impact for the society as well as for the science.
The sensors I'm investigating as part of the Collaborative Research Center can be used in medical diagnostics. It's very rewarding to know that your research can be part of future medical diagnostics and improve people's lives.
Material science is the foundation of so many future technologies, because whatever we build, from clean energy systems to medical devices and digital technologies, starts with right material. It's the link between fundamental scientific discoveries and real-world technologies. We as material scientists have responsibility to ensure that our innovations and technology serve people and planets. That's thinking beyond just performance and cost, considering safety, resource use, and long-term environmental impact in every development.